Hi everyone, welcome back to ANR Academy. This is Nepal sir. Today we are going to discuss Hermite identity. See the statement. For small n belongs to natural number and x belongs to real values, then step x plus 1 by n plus step x plus 2 by n plus and so on plus step of x plus n minus 1 by n, that is equal to step of nx. That is the statement. Let us see the proof of this. Here the statement is given. Step of x plus step of x plus 1 by n, step of x plus 2 by n plus and so on, step of x plus n minus 1 by n. We need to prove step of nx, and here the condition: small n is natural number, x is real number. To prove this result, what I am doing, observe, I am going to use substitution method. Let y equal to nx. If you write y equal to nx, implies the value of x equal to y divided by n, so that the given question LHS changes to step of y divided by n, first term, next plus step of y by n plus 1 by n, next plus step of y by n x is, and then plus 2 divided by n plus and so on, next y by n plus n minus 1 divided by n. That should be step of y. Just by substitution, the given statement changes to this form, so that here it is enough to prove that step y by n plus step of y by n plus 1 by n plus step of y by n plus 2 by n plus and so on, step of y by n by n value 1, remaining minus 1 by n. So it is y by n minus 1 by n plus 1 minus step y, that should be equal to 0. So it is enough to prove this result equal to 0. Assume that this is some function of y. So that here our aim is to prove f of y equal to 0. To prove f of y equal to 0, first write f of y. What is f of y? Actually, by substitution, step x changed as step of y by n. So step of y divided by n. Next term, y by n plus 1 by n. Next, y by n plus 2 divided by n plus and so on. This one, step of y by n minus 1 by n plus 1 minus step of y. This is f of y. Suppose that if you replace y as y plus 1, then what happens? Observe. F of y plus 1 now. In place of y, you have to write y plus 1. So, y plus 1 divided by n, that is y by n plus 1 by n. This is first term now. Next, here if y value y plus 1, again in the second one, get y by n plus 1 by n plus 1 by n, that is y by n. Next, y by n plus 3 divided by n, and so on. Here it is y by n, y replaced by y plus 1, y by n plus 1 by n minus 1 by n plus 1, plus 1 by n minus 1 by n gets cancelled. We get y by n plus 1, and in the last term y changes to y plus 1. Just replace y with y plus 1, that's all. Next, f of y plus 1, that can be written as y by n plus 1 by n. Next, y by n plus 2 by n plus y by n plus 3 by n plus, and so on. Step of x plus integer, you have the property step x plus integer. So here using the property we get step of y by n plus 1. Next, minus, again by the property step of x plus integer is step x plus integer, so that first it is step y, outside minus sign is there, so minus 1. This is result 2. And result 1 here you have, this is f of y, first term y by n, second term y by n plus 1 by n, this is y by n plus 2 by n plus, and so on. This can be written as y by n minus 1 by n plus 1 minus step y. Right. Here just y is replaced by y plus 1. Now observe the terms. Here f of y plus 1 starts with second term from f of y, y by n plus 1 by n, y by n plus 2 by n, and so on. Now apply two minus 1. What happens? Observe. If you do 2 minus 1, second one f of y plus 1. From that we are going to remove f of y. From second result we are going to remove first result, so that these two terms gets cancelled. Next, these two gets cancelled. Next, here 3 by n, and so on. These here it is also gets cancelled, and also you have here y by n. So step of y by n, step of y by n also gets cancelled. Step y with negative sign, these two gets cancelled. Also plus 1 minus 1 cancelled. So finally, on subtracting 1 from 2, f of y plus 1 minus f of y value become 0. Each and every term gets cancelled. That implies I can write f of y plus 1 equal to f of y. So that f is periodic function. We know the definition of periodic function. F of x plus p, suppose f of x, then f is periodic with period p, and hence it is periodic, and period is here in this case 1. So we got periodic function. Suppose for example, if there is a function f of x equal to sin x, you know that its period is 2 pi. Sin x period 2 pi. From 0 to 2 pi, if you draw the graph of sin x, then you will get this one is the graph from 0 to 2 pi. And then after 2 pi, the same graph will appear continuously in its domain. The same here applicable. Here f of y plus 1 equal to f of y, period of the function is 1. So from 0 to 1, whatever the graph you have, the same graph repeats. So here I can say that first in the interval 0 to 1, let us cross check the graph. Only in the interval 0 to 1, cross check the graph. Here it is 0, 1. Suppose in between 0 to 1, if I select input 1 by 2, then what is the value of f of y observed? Graph of f of y we are going to draw. In between 0 to 1, let us try first. If y equal to 1 by 2, what happens? It is 1 by 2n. Now f of 1 by 2 become 1 by 2n with step. Next, second term, 1 by 2n plus 1 by n, and so on. Last term, y value 1 by 2, so 1 by 2n minus 1 by n plus 1 minus step of y value 1 by 2. Observe, whenever input is 1 by 2, since n is natural number, already in the statement given n is natural number. If you write natural number here from 1 to any natural number, whatever you write, it is clearly less than 1. 1 by 2n less than 1. So step of 1 by 2n become 0. So this one 0. It is also less than 1, become 0. And if you write here, also 0. Let us substitute x, suppose n natural number 1. What happens? Observe, 1 minus 1 gets cancelled, just 1 by 2, 0.5. Step value become 0. And step of 1 by 2, again 0. So the set of values, each and every value becomes 0 by writing n natural number. So f of 1 by 2 we got 0. Not only 1 by 2, in between 0 to 1, whatever the value you write in the function f of y, functional values, that is 0. Therefore, for all 0 to 1, f of y clearly 0. In the interval 0 to 1, the graph indicates f of y always 0. So here whatever the value you write, it becomes 0, 0, 0, 0, 0, 0. The same graph repeats. And domain is for all x belongs to R. Yes, domain for all x belongs to R. In this direction and in this direction. Total for all real values of x and n belongs to n. Here in this case, functional value is 0. Here, our aim also the same. Our aim is f of y should be 0. The same we got here. Just replacing y with y plus 1 and subtracting them, we got a relation f of y plus 1 equal to f of y. And from this, I can say that the function is periodic with period 1. So, up to 0 to 1, whatever the value we substitute in the functional value gives the result 0. So, in the interval 0 to 1, functional value 0 implies due to periodicity 1 to 2 also 0, 2 to 3 also 0. In the negative part, minus 1 to 0 also 0. For all real values of x, the functional value is 0. So, here the aim is also the same. If f of y equal to 0, that means finally we reach step x plus 1 by n plus step of x plus 2 by n and so on. Step of x plus n minus 1 by n, that become step of nx. Remember, small n is natural number and x is real number. This is Hermite identity. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to comment. Thank you so much.